Hello. My name is Grayson Morgan. I am non binary and I'm a student at EKU studying computer science with focus in game design. Um, I've worked with a bunch of different platforms and softwares. I've done GameMaker, Unity, Blender, Maya for modeling and animation. Um, I've made my own game engines even in Java, the Java programming language. Um, Back in the spring of 2022, I did an internship at Fritkin Frat Games, which is an indie game development company based in Lexington, Kentucky. Um, this lesson that I've prepared is more so for the high school or maybe upper middle school age group. So I was thinking probably 14 to 18 years old. It goes a bit in depth into specific data types in Java, and it talks more about like the scopes of the data and storage processes and stuff. So yeah, let's just jump right into it. So first of all, what are data types? Data types in Java are ways to store information that the typically the user would enter, but also you can enter in through your own program. So this would be anything from like numbers to strings, which is just like sentences, basic typing. It can be true and false values, stuff like that. We'll get more into specific types in a minute. Different data types have different uses. So if you're just doing something that needs five specific variable values, then you'd probably want to use like an integer. Whereas if you're trying to get specific data for like a common one that I've used is specifically uh, calculating velocity, you'd want to use like a decimal value for that so that you can get more specific and more precise with it. It can also just be like true and false values. And then depending on the data type that you use, it can have different size capabilities or different amounts of data that it is capable of storing reasonably. All right, a couple of the primitive data types that are in Java. Uh, and primitive data types are specifically data types that are already built into the program and that must be assigned a value. So they can't be null. You can't instantiate a primitive type value without assigning a value to it first. And all of the variables also have default assignment values. But yeah, the primitive variable types that we will be covering is booleans, bytes, shorts, ints, longs, floats, doubles, and chars. And then towards the end, we'll talk a little bit about non-primitive data types, which is specifically data types made by the programmer themselves, excluding specifically string and array variable types. Those are built into Java, but we'll get into that later. Starting off with booleans, they're probably the simplest to understand. These are used to store binary variables or variables that only have two values possible. So this is your typical true false question, or it also can sometimes be seen as zeros and ones, just in the binary sense. True is returned whenever a condition is met. For example, if you were to say 1 plus 1 equals 2, that is true. So that would be returned if you were to ask that to a program. And false is what is returned when the condition is not met, such as 1 plus 1 equals 3. 1 plus 1 does not equal 3, it equals 2, so that would return false. Bytes, shorts, ints, and longs are all used to store whole numbers or integers. So this is your typical like -5, -4, so on. The only major difference between these are the storage capacities of each variable. Bytes can store between -128 and 127. Shorts can store 256 times that amount. And ints can store, it just gets significantly larger as you go down. And the most common variable that is used for integers is int, just because it has the storage capacity that most variables that you need whole numbers for would need. But longs are also used sometimes whenever you need something that has more storage capacity. Floats and doubles are both used to store fractional numbers or decimals. The difference between the two is just size Floats can store half as much data as doubles can. Floats typically take up about 4 bytes, or they take up to 4 bytes of data, and doubles can take up to 8 bytes of data. In Java, data management and like storage optimization isn't, it's something that's more so done in the background by the language itself, whereas with like C++, specifically optimizing and increasing performance through data and storage and memory usage is important. In Java, it's not as important. You do obviously still need to be mindful of the amount of data you're storing at a time, but in a general sense, as a beginner, it's not something you really need to worry about. So good to know the different data types, of course, but more often than not, you will use doubles. Char variables are used to store single characters or letters, or ASCII values, and that is based on the ASCII chart, which I'll show in a minute. But this is like any just single letter any single character you could type on your keyboard. So this could be letters, capital and lowercase, or numbers, or symbols. It can even store emojis, and that's done through Unicode. Yeah, so here is the ASCII table. As I mentioned, chars can use Unicode as well, but more often than not, you'll probably use ASCII values if you are using char variables. And honestly, more often than not, you'll probably just use the character itself rather than the ASCII value directly. But yeah, it can store any kind of number or letter and a lot of different symbols, a lot of the like kind of invisible characters. So that would be like tabs, spaces, things like that, shifting in and out, and that's used more so in like word processing documents. Yeah. Now, non-primitive data types are data types specifically created by the programmer, other than the string variable type, which we will talk about in just a second. These data types will always start with an uppercase letter, and they don't always have to hold a value, meaning that they can be assigned to null. Null being just when you don't have any value for it. You'll learn more about class creation and object-oriented programming in a later lesson, but yeah. Non-primitive data types are what you use most often in larger scale projects. So this would be like if you're trying to make a POS system for an ordering, you might have a data type that is called item, and that would be for like a cheeseburger or whatever it may need to be. And that would be more specifically in like an ordering system at like a restaurant, for example. In a more game design sense, this would be like your player character. Your player character is a very common class that has to be implemented in almost every single game project. And even in game design software, such as Unity and GameMaker, these kind of actions and object-oriented programming basics are in there as well. It's just done behind the scenes by the software itself. String variables specifically are built in non-primitive data types in Java. They are one of the only, other than arrays. And we'll get to arrays in a later lesson. But it is a non-primitive data type in Java, and it's used to store strings of characters. So one of the methods that the string class implements is called like string.charat, and I will show you an example of that when we get to the coding. But string.charat is literally taking a specific character out of a string and storing it as a char variable. So this kind of goes hand in hand with chars. Strings are just multiple chars stored in one variable. And this is, for example, hello world, coding is cool, things like that. Yeah. So now I will hop over to the actual coding bit, which is over here. And we'll do a few examples. So something simple we could do is just, let's make a number. Call it int num, and we'll set it equal to 0 at first. And then if we do a print statement, which in Java is written as system.out got println to print and then go to the next line. There's also system.out.print, which will keep you on the same line. But I'm sure we've covered that at this point. For this, we'll do a string number and then throw our variable name in there. And this is a pretty typical way of concatenating strings, is just with the plus symbol in Java. Also in Java, syntax-wise, every single variable or every single line of code has to end in a semicolon. Whereas in other languages like JavaScript, semicolons can be put but don't necessarily have to be. In Java, if you don't put a semicolon, you will get an error, which can make debugging extremely annoying if you miss just even a single semicolon. But yeah, so we'll print our number and then we'll reassign it with itself plus 5, and we'll print out that. Forgot to put my quotes around it, so I'll throw those on there. And this is your standard long form of adding to a number. You can also add to numbers, or add to variables, I mean. Number-based variables, so that would be any of your integer or decimal variables. You can also do plus equals, which is just the short form, and that would work the exact same way. Just copy that down there. And another thing that you can do if you're just trying to increment the value is you can do num plus plus or num minus minus. And those two things functionally do the same thing, except one adds 1 and one subtracts 1. And this is something specific to integer-based variables. You can't necessarily do that with doubles. You can still do the plus equals, but you can't do plus plus and minus minus because they are decimals. So yeah, if we just run the program real quick, then we can see down here in the console, it printed out our original number was 0. We added 5, so it went to 10, or it went to 5, added 5 again, and it went to 10. And then we incremented by 1, it went to 11, and decremented by 1, and it went back down to 10. So that's basic integers. We could do a new one that is, call it double num2, and we'll set this equal to 5 at first, and we'll print that out. And \n just includes another new line onto our current new line, because with each of these, basically it prints and then it adds a new line character to the end of your string. This is just adding another new line character, so it should put one more space down in our console. And we'll take this double and we will, you know what, we'll do num2 plus equals num. And you can add variables like that. Also, another thing we could do is we can assign a double as an integer variable. You cannot go the other way around though, because to take an integer, or to take a double variable and turn it into an integer would be to lose that decimal point, which is considered lossy variable assigning. And it's typically something you wouldn't want. So we will do a print statement for our num2 after adding, and a print statement for our number 3. Now if we run, we get our same variables as before with our num, and then we get that number 2 equals 10, and then we add num to it, which puts it to 15, because we initially set it to 5. Wait, if we initially set it to 5, why is it printing? Oh, because I didn't, that would be why. I didn't do num2. All right, try that again. There we go. Now, number 2 is 5.0, and with double and float variables, they will always include that decimal point, even if it is 0. And then we added num to number 2, got to 15, and then we assigned number 3 with num's value. And you can see, even though we assigned it with an integer, it still includes that decimal point because it is a double variable. But it is set to 10, which is our final value for num. So that all works. Let's get into maybe a string variable. We'll do string s equals hello. And this would be a typical way of instantiating a string variable. And then if we do, you can add number variables to string variables, and that is considered fine. And so if we do hello, number is, and then add num to s, and then we do a print statement. My goodness, there we go. And we'll just print s, print our string variable. Then if we run our program, you can see we get hello, number is 10, which it added num to the end of this string. Same as we would do with the concatenation within the print statement, but this time it's just stored into a variable. And now if we do, for example, char c equals s dot char at, and we'll say indices start at 0 and can go up from there. So we'll do 5, index 5. And since this is an automatically, like we manually wrote this, we know that there is a 6th character. So we can just do char at 5 rather than trying to calculate, make sure it is there. In an actual program, you would, of course, want to make sure that you're not trying to access a variable that is not within the string length, because that would throw an error and your program wouldn't work. So now we'll just do a print statement for C. And if we run our program, we get character number 6 is the exclamation point, which if you count, you'll get 0, 1, 2, 3, 4, 5. This is our index 5 or 6th character. So yeah, that was a basic intro to some data types within Java, and I hope this works.